And folks, for the first big news of the day, Amazon Web Services outage exposes the internet's fragile backbone. So on Monday, a routine backend change inside AWS's US East 1 server in North Virginia turned into a multi-hour internet disruption that was felt across the globe. So a fault in DNS resolution for the DynamoDB API endpoint meant that apps couldn't find their databases, and error rates spiked across EC2 and network load balancers, thereby throttling the core services. And by the time recovery rolled out, millions had experienced failures across social, banking, travel, media, and smart home applications. Look, this wasn't a hack, it was a structural reminder that the cloud's control planes are now critical infrastructure. When one bends, the entire web breaks. And early estimates suggest that AWS outage may have cost companies over 2 to 3 billion dollars globally in just a few hours, with Amazon alone losing around 72.8 million dollars per hour, and platforms like Zoom, Roblox, Canva, and Reddit each losing hundreds of thousands of dollars per hour in downtime. The first red flags appeared around 12:41 p.m. Indian Standard Time or 7:11 at Greenwich Median Time. Requests to the DynamoDB in US East 1 began timing out as DNS lookups failed, cascading into endpoint errors. So internally, an EC2 network load balancer and its health monitoring subsystem also degraded, amplifying the blast radius. By 3:41 p.m. Indian Standard Time or 10:11 at Greenwich Median Time, Amazon signaled recovery, but queues, backlogs, and stale caches took hours to drain. At its peak, Snapchat, Reddit, Venmo, Coinbase, WhatsApp, Signal, Zoom, Slack, Fortnite, Roblox, Apple TV, UK banks, airline system, any other app, be it Amazon's own Ring, Alexa, all of them stumbled. For users, it looked like half of the internet went dark. In reality, a single region's control path was misrouting the entire phase. Let's look at the scale of the event. So we had 113 plus AWS services impacted at peak, while recovery arrived in waves as caches cleared and queues drained. Millions of outage reports landed globally within hours. And the economic hit spanned lost transactions, booking delays, operation slowdowns, and developer productivity stalls from multi-million per hour for top platforms to aggregate billions in lost output. And US East 1 is AWS's oldest, largest, and often the default region, and again proved how concentration creates a systematic risk. Now let me explain what actually failed without much technical jargon. So think of DNS, the domain name system, as the internet's phone book. So now apps don't memorize the server numbers. They ask the DNS where to find their data each time. And the trigger point is that the phone book's entry for DynamoDB's API in US East 1 went bad. And the effect was that apps could not connect to data, it hammered retries and then failed. And what amplified the issue was that EC2's load balancer held subsystem degradation. It increased error rates and throttling. And the aftershock was that even post-fix, message backlogs and stale DNS caches made recovery uneven for hours. So you may ask why so many apps went offline at once. Look, modern apps are layered. You have the front end in the APIs, databases, queues, identity, and analytics, often stitched together with AWS managing its services. So if a single critical layer in a default region, which is the DynamoDB in US East 1, is unreachable, everything above it stalls. So think of a series electrical connections that we all studied in school. And this meant that payments don't post, sessions expire, cards don't save, your notifications die, your live streams hang, and all of your smart devices go dumb. and a localized control plane, its fault becomes a global cascade. Take a look at Perplexity as an example in India. As the AWS incident unfolded, Perplexity AI went down across the country in India. So, down detector spikes showed a major disruption beginning the afternoon of October 20th. And it was not just isolated failures. The company's CEO Arvind Srinivas acknowledged the dependency in a post on X. Perplexity is down right now. The root cause is an AWS issue. We're working on resolving it, end quote. Users report skewed toward website failures around 50%, followed by app failures around 38% and login at around 12%. It was a profile consistent with backend dependency failure and not client glitches. And its restoration hinged on AWS recovery, as no independent Perplexity status update superseded the CEO's note. And we also had an Elon Musk moment and the subsequent fact check. Elon Musk took a swipe at Amazon, noting that X, his social media platform, remained unaffected. He amplified a doctored screenshot implying, which said that 75% of AWS production code was pushed by AI. Soon after, community notes on X flagged the image as digitally altered or misattributed. Musk then touted X's encryption and lack of strange AWS dependencies using the outage to pitch independent infrastructure. And this exchange reignited the debate over cloud lock-in versus platform sovereignty. And this, we can see a pattern emerging. Concentration risk is the new tech debt. Yes, this outage joins a decade of teachable moments. In 2017, we had the S3 incident. A mistyped command failed entire swaths of the web. Then in 2020 to 2021, we had multiple US East 1 events. Control plane service dependencies caused multi-hour disruptions. And now in 2025, we have the DNS or the DynamoDB fault. A small control plane revealed a very large blast radius. The throw line is villainy in its concentration. As more of the world's compute stacks adopt the same regions, defaults, and managed services, resilience architecture becomes the only real moat. Now let's talk about the industry and the competitor reaction. Policy voices frame this as a systematic risk. Economies and public services ride on a few cloud backbones. Practitioners stress the cost and cognition of true resilience. Multi-region and multi-cloud isn't a toggle, it should be an operating model. And vendors seized the moment. Snowflake CEO Sridhar Ramaswamy highlighted cross-region or cross-cloud replication, seamless failover, and centralized governance, positioning DR that spans providers to turn outages into non-events. Expect rivals to market resilient by design architecture with proof of game day drills and DNS fault playbooks and not just SLAs. And AWS has indicated it will provide a post-event summary, which will involve the root cause analysis, mitigations, and architecture changes. Customers should demand it contractually going forward. So we have clean operations for dirty days, and what does it mean for builders to do now? So they need to have a day zero region loss design. Experts across various forums Experts across various forums advocate for active regions for authentication, catalog, card payments, webhooks, and if not for multi-cloud, be multi-region for reads and must not fail writes. Second is to harden DNS dependencies, SAIN TTLs, circuit breakers, negative cache guards, fallback endpoints, and fast cache invalidation procedures. And then comes decoupling control from data. So developers advocate to avoid single choke points, which is one region or one account or one KMS per queue. For global features, use cell-based or partitioned architectures to limit blast radius. And the last is for chaos test reality. Don't just kill pods, break name resolution, or flap endpoints. Simulate API throttling and identity access management or DynamoDB unreachability in US East 1 for an hour. And of course, we also have fail informative and not silent. We have read-only modes that last known good caches, queue and replay, and early in-app communications which beat the spinner purgatory. So what enterprises and policymakers should take away from this? One, we have concentration audits. map hidden third party dependencies, which is banks, tax portals, telecoms, healthcare, that implicitly route through US East 1 or a single provider. Then we have resilience benchmarks, which mandate multi region readiness and post incident drills for critical services. Then we have sovereign continuity, where statutory uptime matters, plan regional diversity, and even cross provider for minimum viable operations. And then we have transparency by default, require detailed postmortems with concrete mitigations and timelines from hyperscalers. But why does this moment matter? Because we have AI, finance, mobility, media, everything now sits on a handful of cloud regions control planes. The internet was designed to be decentralized. Operational convenience made it centralized in practice. And Monday proved that the geopolitics of compute and the craft of resilience engineering are the same story. Models will get smarter and outages will still happen. Winners will design for failure and keep shipping through it. So, joining us today is Ramesh Pudukod, a veteran technologist with over 37 years of global IT experience spanning finance, retail, and cloud infrastructure. So, having worked across platforms from Unix to AWS and now serving as a financial advisor at Primerica, Ramesh brings a rare blend of technical depth and financial foresight. He joins us on front page to unpack the entire AWS outage episodes and what it reveals about global cloud dependency and why it's more than just a downtime incident and how it could reshape enterprise resilience and digital sovereignty strategies. Once again, welcome to front page Ramesh. How does it feel to be a part of the live stream today?
H- Hello, Supreet.
Hello Ramesh. I hope you can hear me.
Oh, thank you, Supreet, for inviting me. It's a great part to be part of the AIM network.
So before I begin asking the questions for the AWS outage, being a veteran in the industry, how does it feel to be a part of this moment where there's so much outage going on in the world and so many apps not working? What was the first thought that came into your mind while you saw the entire situation unfold?
To tell you frankly, these sort of outages have been happening, I would say, frequently nowadays. Therefore, I wasn't surprised. I was suspecting it to be a cyber attack or some hack or something like that. And but I think this is not very surprising given the amount of the infrastructure and the criticality of it, and for a lot of failure points are there. I would say, and I'm not saying it happens very frequently, but it is happening once in a while.
Right. And it's good that you mentioned that it's not a cyber attack of sorts, which is a much needed clarification for many of our viewers across the globe. So, just to reiterate, it was a single DNS failure in one AWS region, folks. So, it effectively stalled large parts of the internet. So, this reveals a structural dependency that goes far beyond the uptime concerns. And it's about how much of the world's digital infrastructure is concentrated in a handful of control planes. Now, while that is clear, when a single region's DNS issue can ripple across industry, so my question to you is how does banking, to AI and how should all the other enterprises rethink cloud architecture? So are we underestimating the control plane fragility in the cloud resilience strategies?
Okay, Supreet, before we go to, because there's a lot of questions within that question, therefore my let's explain to our viewers what really happened. What happened was, there is this domain name system DNS, where you put in a URL, it converts it into an IP address, and um, if someone puts it like say yahoo.com, and it's like a telephone directory, it goes and then looks at the IP address first at your own local cache, then at the ISP level, then it goes to the root directory and all that. There is a lot of procedure in the way it gets it. Now that is the point of failure. That's what I read from the system, from the AWS outage. Basically, it could not get the address properly for the name. That means the applications are all running fine. That means the Zoom is fine, the Snapchat is fine, the Reddit was fine, the Perplexity was fine. All the thousands of uh, apps or companies, they are all their web servers are all,
Right.
their services are running fine. But the problem was the resolution of the DNS was the point of failure yesterday. That's what I read. Now, what AWS explained or gave the reason was that they applied an API updates to their DynamoDB, service, and that was the point of failure. Therefore, that was the point of failure yesterday. Now, that's the software side. Now, on the infrastructure side, this happened in that US Eastern zone
Right.
of AWS, which is in Virginia, which is the very critical. It is called, actually, there is a name called data center capital of the world, because there are about 400 or odd data center, huge data centers in that small area. For a lot of pipelines go through, I am sure, the fiber optics and things. But it did not affect that part. That was not the reason. But just wanted to give our viewers some idea
Exactly.
about how that area is. It's a very, very critical zone in the data center, map. Now, coming back to your question, yes, it is a critical issue. Now it has affected a lot of apps. I don't know about banking, whether banks were affected yesterday, but a lot of social media apps were very popular. AI, like Perplexity platform was affected. Amazon's own um, retail software was affected, and they had losses. It was estimated about something like $70 million a hour or something like that for Amazon. And I think, as you mentioned very clearly, uh, there were a lot of these companies had losses, about hundreds of thousands of dollars per hour. Therefore, it was a very critical system. There was a point of failure over there. Now, the question is, did it happen before? Yes, I think Amazon AWS had a failure in 2021 or
Right.
2022, something like that. And for therefore, that is exactly what happened yesterday. You know.
Right. Right. And thank you so much for doubling down the context. I think this is quite a technical context, and most of our viewers would sort of need reiterating these concepts. So if I were to interpret your response, so US East One is not just a data center, as you mentioned, it's the data center capital of the world, and it's such a critical juncture at it's almost like a geopolitical choke point. We have global businesses, governments, and even AI platforms, like you mentioned, that Perplexity, they sort of depend on it. And outages in hyperscaler regions have real world and economic and even security implications. And given that, as you mentioned, sir, hyperscaler infrastructure like US East One has effectively become a critical national infrastructure. Sir, my question to you is that how should governments and regulators engage with cloud providers to ensure sovereignty and continuity so that these services don't break down at this scale at any point?
The the way we have to plan is, for example, like, say, in India, we need to have our own, ideally, own cloud. Okay, now it could be a hybrid, it could be private cloud, whatever it is. But the thing is, if whichever cloud you design, we have to ultimately have the not a single point of failure. That is the criticality. For that means, for example, let's say, um, I'm just giving you an example, like SBI transactions going on. Now you don't want everything to be on a particular one cloud, so that for online transactions, it's better to be split across, let's say, maybe SBI's private cloud if they have, or Google Cloud and AWS. I'm just saying mix and match of cloud. I know it'll be expensive. It is not that easy solution, but that gives a lot of you know sort of stability in that one. Having said that, the even AWS, for example, has a lot of load balancing, multi zones. They have something like 100 and odd zones across the world, and they have many centers across these zones. Therefore, they do have a balancing. But yesterday was, I think, was like the Virginia, it's the, I think the oldest data center, I think, got affected. Now hopefully they will balance it out. Now that is what I am assuming is, if we were to have the sovereign cloud, we should either go for entirely private cloud or a hybrid cloud. That way there is a balance, that we're not dependent on a particular hyperscaler. But even if we go with a sovereign cloud, let's say for example, thing, we need to have multiple, again, uh, zones in India, and multiple data. I mean, there's centers spread across and things like that. Therefore, it's that's the way I would say we should plan if we are going to do that.
Right. And thank you, sir, for
And
actually
cost
bringing
is
up.
involved,
Yeah,
and so
exactly.
sorry,
Yeah,
so,
yeah,
so cost is involved in that one. Yeah, we have to
exactly.
take into account.
Yeah, I think that's exactly where I was headed next. Of course, building a highly resilient cloud system obviously involves a lot of cost. Even if you're going for a true multi-region or multi-cloud resilience, it isn't cheap. And you have many organizations knowingly accept correlated downtime to save costs. So this outage exposes a very hard truth, right? So what was once a rare edge case is now a business continuity risk. So, sir, my next question to you is that should organizations treat this cloud concentration risk the same way they treat, cybersecurity threats, like let's say board level issues with mandated budgets and all sort of drills to deal with these downtimes?
Oh, absolutely. And the business continuity process, BCP, whatever you call, is very critical. That means very critical industries like banking, airlines, and AI platforms. Nowadays, everything, even social media.
Right,
Um, Therefore, we need to have some sort of a testing where, what if failure type of things. What if, let's say, once one zone is down, I'm sure even the hyperscalers would be have a plan for that one. But the businesses should also plan, and the board and the management have to be on the monitoring about that very frequently, maybe once in, generally we do once in a year type of business
right,
continuity checks, like something will be brought down, and to make sure that the other servers are up, and so that the business is not affected. Yeah, it's a very, very critical thing, and budget has
right.
to be allocated for that. Yeah.
Right, right. I think that's and also, while we talk about budgets, let's also talk about some of the real world impact that you spoke about. And we also had the contrasting nature between Elon Musk's X versus Perplexity. So how Elon Musk used the outage to showcase that X, the social media platform, runs on an independent infrastructure, while Perplexity AI openly acknowledged its AWS dependency. And sir, this contrast highlights an emerging divide between platforms. One is building on a rented infrastructure versus the other it's owning its own critical control paths. Sir, my next question to you is that do you see a shift coming where companies prioritize owning their own core infrastructure versus relying on hyperscalers like AWS despite repeated outages like the ones we saw today? So do you think more and more companies will move towards owning their own infrastructure and the critical control aspects?
um, to answer your question, before I answer, you gave that X, Musk's
Right.
remark, but
Right.
actually, Supreet, if you know, X has was down last few years, like two, three
Exactly.
times, I think. Okay.
Exactly.
For it's not that his ecosystem, his infrastructure, and his thing is perfect. For um, and compared to AWS, I'm sure he had he had more failures in the last few
For
years.
sure. Yeah.
The other question is Perplexity. Yeah, Perplexity is dependent. A lot of companies that something like yesterday, like thousands of companies were affected yesterday.
Exactly. Right.
Okay, and big and small. The big is,
Of
the
course.
most major one is Amazon's own um, retail stores. They got affected. To probably a mom and pop startup somewhere, using AWS for their EC2 or whatever storage. Now, um, the question is, can one start every see? it's not can one start, that's what that was your question,
Right.
in your own storage. it is it is yes and no, but it is not that simple. And also, if I am a small startup, let's say I am a startup, one man startup, two men startup, two people startup or whatever, and I don't want to, it costs a lot of money to get the web servers, there's the software, you have to license, your SDKs, tools,
Yep.
databases, hardware, networking, and that's not practical at all. Whereas I can go, I can open an account on AWS or any of the hyperscalers and get access to the whole environment, from networking, databases, servers, everything, and I don't have to worry about all this stuff. Therefore, I don't think it is practical to go, for their own cloud, private cloud. Now for a big corporation, yeah, it makes sense, it might make sense, I'm not
Right.
saying no. But for most of the people, or most of the companies, it may not be worthwhile. And this is probably the easiest way to get your startup or business up and running, which is the cloud, you know
Right, right. And while we discuss the what ifs and what nots or what maybes in the future, let's talk about more about what is to come in the near future. So it's very likely that Amazon's going to obviously take up accountability and they're going to release a very transparent post-mortem report. And which is, they'll release a post-event summary. But unlike regulated industries, cloud infrastructure providers face minimal public accountability, right? So you have enterprises, developers, and government, they depend on AWS infrastructure. And yet, sir, transparency remains very limited. So, my question to you is that now we have cloud outages of this scale, and should this trigger mandatory transparency and accountability measures? Similar to how public utilities, sort of report failures, do you think the government or the regulators should sort of step in and, build a framework or a regulatory framework to ensure that these outages are handled better in the future?
Absolutely. I would say the company AWS, or whichever company it is,
Right,
should come
exactly.
out and, uh, as you mentioned, they should release the reasons behind it and how they are fixing it and how they will avoid future outages like this. And that is very important. And I don't know whether there should be a government mandate or something like that, because it's like, if they have a lot of outages, obviously no I mean, customers will switch from one hyperscaler or one cloud provider to another. Okay. For I don't know whether government should be involved in this, because it's more like a private, just
Hmm.
like, let's say I have my own server, and if I don't maintain the server, then my business is at loss. The same
Exactly.
way, okay. Um, Therefore, I would not involve government in this one, if I understand your question correctly. But it's more like a, Amazon or whoever it is, the companies, they should come up with their own
Hmm.
reports and monitoring, and making sure that they are transparent as to what was the problem. Yesterday I was reading that it's not a cyber attack. That's what I read.
Yeah,
they
of
they
course.
admitted saying it was internal API update
Hmm.
to their DynamoDB services that what created the problem. That's what they said.
Right, right. And so my last question to you is, such a centralized infrastructure which leads to an outage of this scale, what does it mean to a country like India? Now, of course, we almost have the second most number of, AI users across various platforms, or even let's say social media or other internet services. So, besides that, India is rapidly, digitizing critical services. We have UPI, ONDC, and many AI startups, and we also have many sovereign cloud initiatives. But many of these layers, as we're discussing, still depend on a foreign hyperscaler infrastructure like AWS. And as we just spoke about, a single outage in US region also disrupted many Indian platforms. And it also showed how global incidents can ripple into domestic systems in India as well without warning. So my question to you, sir, is that as India builds the digital public infra and a brand new AI ecosystem, what does this AWS outage reveal about our over reliance or over dependence on global cloud players? And how can a country like India balance rapid scale with digital sovereignty, resilience, and local compute capacity?
Yeah, I understand where you're coming from. That if we are looking at our UPI, our what do you call ONDC, online digital commerce, something like that. Okay, a lot of transactions. UPI is generating about 800 million
Yeah,
transactions or something per day. It's about the largest um, transactions. About 40-50% of the world digital transactions are generated by UPI. Okay,
right,
now but if you look at it, the way I understand was the payment provider like Google Pay or Phone Pay owned by Walmart and Google Pay, they are responsible for the transactions to store,
yeah,
and the banks are responsible also on their end. Therefore it's distributed, I would say. That I think that's what it is. That is, you can get your transactions from either way. I think you can access, I think both of them store the transactions. Now, can we are, yes, as a digital economy, it's the dependence on these hyperscalers are becoming very, very
right,
critical. Now, just want to give an idea to the viewers
right,
how these hyperscalers are dominating. Nearly 65 or 66% of the market share is dominated by AWS, which is about 30-32%, Azure, which is about 20-21%, and Google Cloud, which is about 13% or something.
right,
Okay,
roughly,
these
yeah,
three dominate about 65-66%, two-thirds of the whole global cloud uh, transactions.
right,
Therefore, it is very critical that all businesses, everyone is dependent on this, and there should be an uptime on that. But coming back to your thing, can we again can we go back and replace them? Yes, for major corporations, like, okay, I can understand, they may have the the financial resources, but for a lot of small to medium to even to some of the larger, it becomes very expensive to have this own cloud infrastructure, on their on prem. The For example, I just want to let you know,
yes,
uh, AWS has got like 14 million servers, 14 million across the world. For And they distributed it, and they have these zones and availability
mm,
zones, and all sorts of data center across spread across the world. Now that gives a lot of stability. Now, even then, it happened yesterday. Therefore, there is no guarantee that nothing can happen. Now, to replicate that for an organization is difficult. This is the hardware infrastructure. Now I'm talking about, let's take the software. Look at what AWS provides, as I was telling you, like for a startup or for a company also. Okay. Now, let's say, for example, okay, you're working in for TC, like a TCS type. Okay, now you are on AWS or on one of these major things. You have all sorts of tools available on that system.
right,
Therefore, they have something like Bedrock. That means with an API, you can call the Chat GPT, or you can call Claude, or you can call Gemini or Grok or DeepSeek, or everything is provided on the Bedrock. Okay, now that is something. Now, for each company, if they have to plan for that sort of a thing, it will be quite expensive, and it may not even be feasible. Okay, same thing
right,
with databases. AWS comes with NoSQL databases, SQL databases, unstructured
mm,
data, file systems, expandable servers. Okay, they're EC2, and their storage S3, and plus a lot of development tools.
right,
For
right.
all these things make it very difficult to replicate. Even though theoretically yes, but practically very expensive. That's what I feel.
Right. Right, sir. Thank you so much for all of your insights. I'm sure it was very valuable to our viewers as well, because this is quite a very tech heavy concept coming in for the first news of the day. But it's also very important to understand why these outages happen, how to prevent them, and what is the cost of preventing them. And once again, Ramesh sir, we highly appreciate your interest in coming in on the live stream and providing our viewers with valuable information. So, folks,
Thank
you
you,
heard
Supreet.
it right, sir. Thank you so much. Sure.
Thank you
So
all.
sure, Ramesh. Sir. Thank you so much for joining in, folks. That was Ramesh with the code. He's an expert in the cloud domain, and you heard it from him with regards to the impact of the outage. And we'd like to repeat again that this wasn't a situation where the internet broke. It was a very precise DNS failure for the DynamoDB database in the US East one, and a very precise lesson that the cloud architects are who own the blast radius. So you have one region, it's a one DNS miss and a global wake up call. And the next time, the difference between the headline and the footnote will be your runbooks, regions, and rehearsals to prevent such outages. And before we jump into the next news of the day, folks, we'd like to take a short break. But don't fret, we have a lot more exciting updates coming your way, especially if you're a young student. You might want to stay for the stream. So stay tuned and let's catch up after the break.